Good day, students. We're doing the current electricity basics lecture today. It's about the definitions, working and measurements of electric currents. We are going to use a very simple circuit. This circuit just consists of a battery, a resistor, and what is then the flow of current? Well, electrons always flow from the negative pole of the battery around to the positive pole. So it is the flow of charges. That is what the definition of electric current is. Then if I take an enlarged piece of wire, and that means I put it on a magnifying glass, what will I see inside my conductor? Well, way back in chemical bonding, you learned about atoms in metals always bond via metallic bonding. That means that we've got a sea of delocalized electrons. That means that the electrons simply move around in all paths in the atoms and in the metal. Right, so when the battery was connected, electrons will then flow in one direction only. That means it will flow back to the positive pole. If we then insert an ammeter in the circuit, then we look at what does the ammeter do. An ammeter always measures current strength. Current strength has got the symbol I, and how do we define current strength? Well, current strength is the rate of flow of charge. Charge has the symbol Q. Then I'm going to define current strength. Remember, current strength had the symbol I, so in a formula it's going to be, now remember also that when you say the rate of something, then it is always divided by time. So what is divided by time? The amount of charge. So I equals Q over delta T, which is the rate of flow of charge. If we reorganize the variables, then you will get Q equals IT. I'm sure that you're all familiar with that formula. And then if we put everything, all my variables in terms of units, then it will be 1 ampere. Now ampere is the unit for I, and coulomb was measured in is the unit for charge, and seconds the unit for time. So it is 1 ampere equals 1 coulomb per second. And then always remember that an ammeter will be connected in series. Why? Because it is just counting the charges in a certain time flowing through the conductor. It must be in series because the charges need to flow through the ammeter. Since the charges need to flow through the ammeter, it must have a low resistance. The charges are to flow easily through the resistor. Right. Now let's look at a voltmeter. Now a voltmeter is connected over the resistor, and what does a voltmeter do? A voltmeter measures electrical potential energy difference in volts with symbol V. Now remember, electrical potential energy comes from your battery, and there's going to be a difference between the 2 points, that point and that point, because some of the energy will be transferred when the charges flow through the resistor. But electrical potential energy difference is such a long term, so it was made shorter by removing 2 words. So we are generally speaking about the potential difference. So the function of a voltmeter is to measure potential difference, for short PD, in volts. Now let's define what potential difference is. Potential difference is the energy per charge. It's very important that you use those 3 words, energy per charge transferred between 2 points in a circuit. Okay, so if you put that into mathematical symbols, it will be V equal to, energy is always measured in joules with the symbol W, per means divide, charge is measured, or will be the Q, symbol Q. Right, in units we say that it is 1 volt equal to 1 joule per coulomb. Right, always remember that your voltmeter is connected in parallel. And why is that? Because there's 2 points in your circuit. One with high energy because the charges came from your battery, and then they transfer the energy and they have lower energy. So the resistance is just removing some of the energy from the charges. Remember also that the voltmeter having a high resistance means that no current will flow through it. It simply is an apparatus taking a high and a low energy reading and calculating the difference between those energy readings for the amount of charges that flow through. Remember that if 5 electrons flow through your resistor, then 5 electrons will come out the other side. I'm just using 5 for argument's sake. The same amount of electrons that flow through the resistor will get out the other side. They will just have less energy. Right, as a summary, everything appears on the next slide for future reference. So, just one thing that I need to emphasize is that the department or in the papers they usually ask what is the definition of current. Now remember that current is the flow of charge. And then there's another question that can arise, which is give the definition of current strength. Now the answer to that would be the rate of flow of charge, not just the flow of charge. But nowadays I see in the departmental papers they ask the question define current, but they actually want the answer for current strength. So I suggest you write both of them. If they say define current, you simply write it is the rate of the flow of charge. Now that's all for today. The follow-up lesson on this will be on Ohm's law.